Hi, and welcome to Probability Section 1. Today we're going to talk about sample spaces and the fundamental counting principle. So, first, let's talk about sample spaces. Sample space is all the possible outcomes. So, for example, if I flip a coin, I could get a heads, I could get a tails. That is it, what could happen for a coin. Or, let's say I roll a dice. I could get a 1, 2, 3, 4, 5, 6. That is the sample space. Sample space are all the possibilities that could happen. Now, sometimes we take multiple events and break them down. So, for example, let's say I'm going snowboarding. A snowboarding goods store offers 3 types of snowboards, all mountain, freestyle, and carving, and 2 types of boots, soft and hybrid. How many choices does the store offer you for equipment? So, I'm going to need to take one of the snowboards and one type of boot. Well, I can break them down individually into the first choice, event 1, in this case, snowboards. And all these branching different timelines I could do. So I could do it all mountain, I could do a freestyle, or I could do a carving. Now, once I select a snowboard, I'm going to select option number 2, the shoe that I want. In this case, boots, the soft or the hybrid. So technically speaking, if I follow this path right here, I would be an all mountain board with soft boots. That is one possibility I could have. And each of these 3 snowboards has 2 possibilities, so we end up with 6 total outcomes. And where does the 6 come from? Well, if I have 3 snowboards and 2 boots, I can multiply them together to give me that 6. This idea of multiplying individual events is going to come up a little bit later. That's called the fundamental counting principle. So let's try another example here together. Let's say I go into a restaurant and I'm going to get an entree and a side. So part B says state the number of objects that can be created, aka how many different combinations. Well, I have 3 choices for an entree, and I have 3 choices for a side. So I could do 3 times 3 to get 9 different meals that could happen. This would be part B. Part C says list the sample space, which we are going to do with the diagram. So first we have to pick an entree. I could pick chicken. I could pick fish. And I could pick pasta. So that's my entree selection. And then moving on, I have to pick a side. For the chicken, I could pick corn. I could pick green beans. And I could get a potato. For fish, I could get corn. I could get green beans. And I can get a potato. For pasta, I could get corn. I could get green beans. Or I could get a potato. Which means if I were to list out the sample space, which it says list the sample space, I could go chicken and corn. I could go chicken and green beans. Chicken and potato. I could go fish and corn. I could go fish and green beans. I could go fish and potato. I could go pasta and corn. I could go pasta and green beans. I could go pasta and potato. Which gives me 1, 2, 3, 4, 5, 6, 7, 8, 9 total possibilities, which makes sense because that was what we said earlier. We get 9 meals. So that is all about listing the sample space. As we talked about previously, the fundamental counting principle is list the total number possible, and the operation we are doing between events is multiplying. So, for example, Mr. Syme has 10 shirts, 5 pairs of pants, 3 belts, and 4 pairs of shoes. If he's not worried about whether the outfit matches or goes together, he figures out that he can multiply all those numbers together to find 600 possible combinations or outfits that he could construct. So let's try another one. So we're going to do some license plates. In problem A, digits and letters can be repeated. So we can see that we're going to get 4 letters followed by 3 digits. So my license plate is going to have 4 letters. So 1, 2, 3, 4, and 3 digits. So those are just going to be numbers. Now, the nice thing is because I know that the letters can be repeated, the first spot, how many different letters could I go there? I could get 26. Because they can be repeated, no matter what letter I pick here, I still have 26 different letters to pick from in the second letter spot. Same in the third and fourth letter spots. Numbers. You actually get 10 digits to pick from because you'd get 1 through 9 and 0 that can go in that license plate spot. And because those can be repeated, I can fill those in with 10 as well. So I would get 26, 26, 26, 26, 10, 10, 10. The fundamental accounting principle says I multiply all those numbers together. So we're going to multiply it. So we get 26 times 26 times 26 times 26 times 10 times 10 times 10. So we get 456,976,000 for part A. Now part B says they cannot be repeated, but I still have the same number of letters. So I'm still going to have 4 letter spots and 3 number spots. Okay, I have 26 letters to pick from right away. Now, no matter what, a letter has to go there, which means I can't use that letter again. So how many other letters can I pick from? That would be 25 different letters. Well, now I have 2 letters that aren't the same there. So now I only have 24 letters to pick from, and now I only have 23 letters to pick from. For numbers, I have 10, then 9, then 8, because I can't repeat the letters. So I'm going to multiply all of those together. So we get 258,336,000. Okay. And it should make sense that because I can't repeat letters, I just have way less possibilities. Okay. The lockers at YHS have dials that are numbered from 0 to 49. How many possible combinations are there if 3 numbers make up a combination and they can be repeated? So I only have 3 spots. Well, if I could do any number from 0 to 49, that's actually going to be 50 total different things that could be there, because 1 through 49 would be 49, and then 0 is an extra one. It can be repeated, so I'd also get 50 in the other 2 spots as well. So I can multiply that all together, and I'm going to get 125,000. Thank you for listening, and I hope you have a great day.